Bright Tuty. Every student matters.
Hello students, my name is Sanjay Jain. In the previous lecture on circles, we discussed about various properties of circle and we discussed about the notion of a tangent to a circle, right? In this chapter, we will discuss about tangents from a point on the circle and various questions related to that. So let's start with this lecture. Let us say there is a point inside this circle, okay? In this second case, we can have a point which is on the circle, and third case can be that the point is outside the circle, right? So how many tangents can you draw in this case? You have to draw the tangent from this point on this circle. So if you try to draw a tangent here, you will draw only secants. These lines are secants, not the tangents. So how many tangents can you draw? Zero number of tangents, right? When the point is on the circle, how many tangents can you draw? One tangent only. We studied about this in our previous exercise, that if there is a point on the circle, from this point we can draw only one tangent. If you try to rotate this line or if you try to find another tangent at this point, you will end up finding a secant, because if you rotate this, it will cut the circle at 2 points. So it will become a secant. So only one tangent is possible if the point is on the circle. Now if the point is outside the circle, how many tangents can we draw? One, and then there is this, two, okay? So if the point is outside the circle, you can draw two tangents from that point, right? So let's discuss about this scenario in great detail, okay? Let us say we have got this circle and there is this external point P. Let's draw the two tangents here, okay? Let us say this is the center O. O is the center of the circle, right? Now if you join the center of the circle and this point of contact, this is the point of contact where the tangent meets the circle, right? So if you draw this line, this angle will be 90 degrees, because from the previous exercise we know that the angle between radius of the circle and tangent at the point of contact is 90 degrees. So what will be this angle? This angle will also be 90 degrees, right? This much we already know, okay? So now if you draw this segment OP, right, joining this point P with the center O, it will divide this in two triangles, this triangle and this triangle, right? Let's name these points also. Let's name it as S and let this be T, okay? Now we will focus on triangle PSO and triangle PTO, okay? Let's look at these triangles. What is this length SO? This is the radius of the circle, right? Similarly, OT is also radius of this circle. So SO is equal to TO, right? Why? Because these are radii of the circle, okay? Radii is the plural for radius. Now what is other thing common in these two triangles? This length PO, okay? So this length PO is common to both the triangles. PO is equal to PO, of course, and this is common to both the triangles, okay? This point is P, okay? Now what is the other thing that you can see which is equal in these two triangles? This angle PSO is equal to the angle PTO. Angle PSO is equal to angle PTO, right? Why? Because both are equal to 90 degrees, right? So from these three results, what can you say about these two triangles? There is this angle 90 degrees and this angle is also 90 degrees, okay? And the side opposite to this angle 90 degrees is equal in both the triangles, and there is another side which is equal in both the triangles. So I can say by right angle, hypotenuse and side congruency criterion, right? Triangle PSO is congruent to triangle PTO, right? These two triangles are congruent because of the RHS congruency criterion, which you studied in class 9th, that if two triangles have their hypotenuse equal and the right angles obviously are there and one of the sides is equal, so we can say by RHS congruency these two triangles are congruent. Now PSO is congruent to triangle PTO, so PS is equal to PT. This is an important result which says that this tangent here and this tangent here are equal in length. So tangents drawn from an external point on a circle are equal in length, right? There are other results which are also equally important, which we can draw from this congruency, which are that if triangle PSO is congruent to triangle PTO, we can say that angle POS is equal to angle POT, right? This angle here is equal to this angle. If we name this angle, let us say theta, so this angle will also be theta. Okay, this is an equally important result. Okay, now you see in these two triangles, if this angle is equal to this angle and this angle is equal to this angle, so we can say that this angle is equal to this angle, right? If this angle is alpha, then this angle is also alpha, right? So these are some of the results that should be at the back of your mind while solving the problems. Okay, that these two angles are equal, these two angles are also equal. What can be the other result that we can draw from this? If you look at the quadrilateral PSOT, look at the quadrilateral PSOT, you see that angle PSO is 90 degrees and angle PTO is also 90 degrees. So what are the other two angles? You see in this quadrilateral, angle PSO is equal to angle PTO is equal to 90 degrees. Okay, and sum of the internal angles of a quadrilateral is equal to 360 degrees. So angle SPT plus angle SOT plus these two angles, right, PSO and PTO, sum of these angles is equal to 360 degrees. But we know that this angle and this angle are equal to 90 degrees. Okay, so what I can say, angle SPT plus angle SOT, if I put it equal to 90 and this is also 90, will be equal to 360 minus 180, which is equal to 180 degrees, right? So this angle here and this angle, sum of these two angles is equal to 180 degrees. This is pretty obvious if you look at this quadrilateral. Just if you take a glance at this quadrilateral, you can see that these two angles, sum of these two angles is 180. So rest of the two angles will also be supplementary. By supplementary I mean that their sum will be equal to 180 degrees, right? You know that the sum of internal angles of a quadrilateral is equal to 360. We know about these two angles, that sum of these two angles is equal to 180. So what are the two angles left? This one and this one. So their sum has to be equal to 180 degrees. So these two angles are supplementary. Which angles? One that is subtended at the center and another which is between the tangents, right, at which the tangents are inclined to each other. Okay. Other result that we can draw if you look at this triangle only, triangle PSO, I'll make a fresh figure and then we will discuss these results. But right now look at this figure here, triangle PSO. Okay, sum of the angles in a triangle, internal angles, is equal to 180 degrees. So if this alpha plus theta plus this angle here, this is 90 degrees, it is equal to 180. So I can say alpha plus theta is equal to 90 degrees, right? So this angle alpha and this angle theta is equal to 90 degrees. So what are the results that we could find in this figure? Let us draw this fresh figure here, and this is the external point. These are two tangents. Let us say this is the center, okay, and let's join the center with the points of contact. So this angle will be 90 degrees, and let's join this point with the center here. Okay, now I am not naming these points, I am just asking you, if this is an external point, this is the center of the circle, so what will be this angle equal to? Let us say this angle is beta, right? Where do you see another angle which is equal to beta? This angle, right? We just talked about it here, right? This angle is equal to this angle. How? We proved that these two triangles are congruent. Okay, let's talk about this angle here. If this angle is alpha, what will be this angle? This angle will also be alpha. Okay, so this line here, this line is angular bisector. Right, this line here bisects this angle. Okay, what is the other result? That this tangent is equal to this tangent in length, right? These two tangents drawn from external point are equal in length. So these are some of the important results that we could find out, right? Another result was that this angle here and this angle are supplementary, right? Sum of these two angles is equal to 180 degrees. We just had a glance at this quadrilateral and we could draw this result, right? In this quadrilateral we know that sum of these two angles is 180, these two angles, right? So the rest of two angles will also be of 180 degrees, right? Their sum will also be 180 degrees. So these two angles are supplementary. Another result that we could find out was that these two, sum of these alpha and beta, alpha plus beta is equal to 90 degrees, right? So these are the results that we could draw from this discussion. Another case that we can discuss here, if I draw two tangents from this point, okay, and this is the point of contact, let's join it with another point of contact and let's draw this segment also. Let's name these point as P, S, T, O. Okay, if I look at this chord here, chord ST, chord ST, okay, I want to know what is this angle equal to, this one. Okay, we already know that this angle is equal to this angle. So if this is theta, this is also theta, right? This much we already know. And this segment is equal to this segment because these are equal to radius of the circle, right? These two things are clear. And this segment here, let's name this also OM. OM is equal to OM, right? OS is equal to OT, and angle SOM is equal to angle TOM, right? So I am looking at these two triangles, triangle SOM and triangle TOM, right? This one and this one. Okay, if you look at these two triangles are congruent by side angle side congruency criterion, because this side OM and this side OS in this triangle, and in this triangle OM and this side OT, right? So OM is equal to OM, OS is equal to OT, angle SOM is equal to angle TOM. So what can I say about these two triangles? That these two triangles are congruent. If these two are congruent, then you see the angle opposite to OS, which is this angle, let's name this angle as angle 1, okay, and angle opposite to OT, let's name it as 2, okay. So angle 1 is also equal to angle 2 by CPCT, corresponding parts of congruent triangles. So if OS is equal to OT, the angles opposite to OS and angle opposite to OT are also equal, right, by CPCT. So we can say that angle 1 is equal to angle 2. But you see, this is a straight line, so angle 1 plus angle 2 we know is equal to 180 degrees, right, straight angle. So from this I can say angle 1 is equal to angle 2 is equal to 90 degrees, okay. So this is another important result, that the segment joining the center and the external point from which the tangents are drawn, this segment, and the chord joining the points of contacts ST are perpendicular to each other, right, because this angle is 90 degrees here, okay. Let me draw a fresh figure for this. Let us say this is an external point, okay, and these are the radii. So what I am trying to say is that if you join these points of contacts here, this angle will be 90 degrees, okay. So this line which is joining the external point and the center of the circle, and this chord which is joining both point of contacts are perpendicular to each other, okay. I hope these much results are clear to you. Another result that we discussed in class 9th also can also be revised here, that if there is a chord, let us say this is a chord here PS, okay. If you have this center here, right, if you drop a perpendicular from the center on this chord, right, if you drop a perpendicular from the center of the circle to any of the chords, it divides the chord into two equal parts, or we can say it bisects the chord. Why? Because if you join these points, okay, you will see that this segment is equal to this segment, OP is equal to OS. Why? Both are radii of the circle. This length is common, right, this perpendicular OM is common to both the triangles, and this is the perpendicular, right. So this angle is equal to this angle, okay. So again by RHS congruency, this triangle is congruent to this triangle, okay. I am not writing these things because you already know these things. So this triangle is congruent to this triangle, hence we can say this length PM is equal to length MS, this length PM is equal to length MS, right, by CPCT. So if you draw perpendicular from the center of the circle to any chord, right, will bisect it, okay. So if you have a circle and you have any chord, and if you draw a perpendicular from this center to this chord, this will bisect it, right, this is perpendicular, okay. So these are some of the results that you should keep in your mind before proceeding. Let me tell you one more thing which is also a basic thing in geometry, that if you have got two parallel lines, okay, if you have got two lines, okay, now if you have this line here, and if you can say that this angle and this angle are supplementary, right? If let us name this as angle 1, this as angle 2. If I can prove that angle 1 plus angle 2 is equal to 180 degree, what can I say about these two lines? Let's name this as L and this as M. If angle 1 plus angle 2 is equal to 180 degrees, what I can say about L and M, that L is parallel to line M. Line L is parallel to line M. What are these angles named as? These are co-interior angles. Right? If you have got two parallel lines, then this angle 1 and angle 2 are co-interior angles, and their sum is equal to 180 degrees. And other way around, if you can prove that angle 1 plus angle 2 is 180 degrees, then you can say that line L and line M are parallel to each other. Okay. And the other thing, if you can prove that angle 1 is equal to angle 3, these are alternate interior angles. Right? This will be another way to prove that these lines are parallel. And if these lines are parallel, then we can say angle 1 is equal to angle 3. This is one and the same thing, because 3 is nothing but 180 minus 2. Right? Angle 1 is equal to angle 3. Right? Alternate interior angles. And angle 3 is what? Angle 3 is 180 minus angle 2. Okay? So I can say angle 1 plus angle 2 is equal to 180 degrees. Right?